There's teapot 1 over there. And it gets the mesh of that value, of that teapot, I should say. So what it's doing is it's getting the mesh of that teapot and it's applying it to the mesh of that particle. And it's that line that actually makes, if I move the window out of the way for a second, it's that line that actually makes the particles appear as teapots immediately. Now, if you have a look at this teapot here, you can see it's got 2 segments. If I change it to 3 and go back, you'll actually see that teapots have got a little bit more detail now. If I make it a little bit, quite a bit more detailed, you'll actually see that a little bit more clearly. That it's not actually updating because I've got this cached. So if I go into here, clear the cache, go back to the beginning, clear the cache, and then run it through, you can see now that the teapots are actually much more detailed. And it's just caching that for us. There we go. It's faster now. So that's what that line does. It actually assigns the teapot shape. Now, this is a conditional statement. It's an if. And it's saying if, then do this. But if it's false, it'll do something else. So it'll do this else statement here. So if the particle is older than 15, if this is not true, don't forget this is a test here, and it says if the particle is less than 15 frames old, then do this. If it's not, it'll do the else statement. The else comes here. So if it's false, in other words the particle's older than 15 frames, it'll do what you have in between these brackets. Now this is where it gets a little bit more complex, but the foundation of it is that it's actually taking another mesh, which you can see is from an object called torus 1, and there is torus 1. Now if I turn off this script and I turn off this entire flow, and I'll just move this window over here for a second, and if I run through here, you can see that this torus is doing nothing. It's not animated whatsoever. But during the playback of the particles, you saw that the toruses that were being applied to the particles were animating. Well, that's actually just an illusion, and I'll show you how that's actually achieved now. I'll go in and turn the script back on, and I'll turn the flow back on, and I'll turn the script back on. What it's doing is it's taking the torus and it's modifying the number of sides that it has, and it's making that equal to 400 divided by the age of the current particle. So you can see that as the particle gets older, the sides of the torus actually gets reduced. So that's as simple as that. On frame 1, this will be 400. On frame 2, this will be 200. On frame 3, this will be 50, and so on. So this number gradually gets less and less and less. The next parameter of the torus that gets changed is its radius. You can see radius 1. Now, what it's doing with that is it's saying it's equal to the particle's age minus 14.9 divided by 2. So that's just something that I've arrived at, and I found that in this particular case that gave me the right kind of radius, and it made the radius change size at the kind of rate that I wanted to. In your case, you can fiddle with that value, and you can see what happens when you do so with that. Have an experiment around with these values and see what you can get with it. The next line does the same thing for the radius 2 value. Radius 2 here. It says radius 2 is equal to 6 divided by the particle age as a floating point value divided by 14 times 100. So, you know, that's a bit of a mouthful, but again, I arrived at that through trial and error, and that basically made the torus's radius 2 value change size at the kind of rate that I wanted it to. The last value that we change is the segmentation, and that is equal to the particle's age divided by 3 plus 8. And that sets up the segments. And the last thing that happens inside here is we get the particle shape, same as up here. We get the particle shape and we make it equal to the torus's mesh. So what that does is it obviously modifies the torus on every frame, and then it basically takes a snapshot of that mesh and it applies it to the particle. And it's doing that for every particle, and it's doing it. These values are obviously individual to each particle on each individual integration step. And the last thing in the script is, on the release of this particular script, do these things, and we don't need that. I found most of the time when I'm working with scripts in particle flow, on release Pt.3, don't use that very often. On init Pt.3, don't use that very often. The areas that you generally always use would be on channels Pt.3 and the proceed area. So it's the channel used and the proceed area that you actually use all the time in your particle flows scripts. So I'll just shut that down there. So as you can see, it's a relatively simple script. It may seem complex to you if you're not a scripter or you're new to scripting in particle flow, but if you have a dabble around with a script of that level, you'll actually find that you can get used to it quite early on. It's very easy. I mean, as an example, try taking that script and taking out everything apart from the mesh assignment. So try taking it out so it just assigns the teapot, and you can then see exactly how that works, become familiar with that, and then you can build it back up to the sort of script that I've shown you there. And you know, it is just an example, but the cool thing is about, you know, scripting and particle flow is that, you know, with a small amount of time invested, you can start doing things that other users simply cannot do using just the standard operators. And you know, this will give you a greater level of creative freedom when you're doing your particles, and you know, professionally it's going to give you the edge over other people. So I would, you know, very much recommend learning scripting, and as I said, you know, Laszlo's DVD is a really good starting point on that journey if, you know, you haven't actually started on it yet. So okay, that's the script operator. And bear in mind that the example I've shown you here is just that. It's just an example. You can do pretty much anything with a script operator with patience and you know, willingness to learn. It's well worth pursuing, as it can often get you out of a corner that the standard P-flow operators cannot, and quite simply opens up a whole new level of power. And I mean, you've heard the phrase power user. If you want to be a power user in particle flow, try to learn scripting, because it will make you into a power user. Okay, that's it for this DVD. Let's move on from here on to the conclusion.